Welcome to KKPBT Online Training by Vicky. Have you ever wondered how smart AI systems make decisions and take actions all on their own? Today, we are breaking down the concept of AI agent architecture in simple terms. Think of an AI agent architecture as a master blueprint. It is the framework that dictates how an AI perceives information, processes options, and acts to reach a goal. At the core of the architecture is the brain. This central reasoning module, often powered by a large language model, processes user requests and decides what to do next. To solve complex problems, agents need planning and memory. The planning engine breaks big tasks into smaller steps, while memory stores recent context and long-term knowledge. An AI agent isn't just a chatbot, it uses external tools. Through APIs, web browsing, and database access, the agent can perform real tasks in the physical or digital world. Consider an online store. An AI support agent receives a refund request, checks order details in a database, applies company policy, and processes the refund instantly. Architectures vary in complexity. They range from simple reactive setups that respond instantly, to multi-agent networks where multiple specialized AIs collaborate together. Whether powering coding assistants or managing global supply chains, well-designed architectures make AI truly useful. Thanks for watching, and subscribe for more tech insights. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Have you ever wondered how an AI agent actually works under the hood? It is not just a chatbot answering questions. An AI agent can take a goal, think through a plan, use tools, and complete real tasks for you. Welcome to our beginner guide on basic agent architecture. Today, we will break down the step-by-step blueprint of how AI agents are built using four main parts: perception, the brain, memory, and actions. Let's get started. Step 1 is perception. This is how the AI agent perceives its digital world. Instead of eyes and ears like humans, digital AI agents receive text prompts, user files, environmental signals, or incoming API data. Perception is all about gathering the input so the agent knows what task needs to be solved. Step 2 is the brain, which handles reasoning and planning. The core of this brain is a large language model, or LLM. When the brain receives input, it breaks the big goal down into smaller, manageable steps. It thinks about what needs to happen first, what to do next, and which tools to pick to get the job done right. Step 3 is memory. An agent needs memory to stay smart. Short-term memory keeps track of the current chat conversation. Long-term memory helps the agent look up past information and external knowledge stored in vector databases using techniques like retrieval augmented generation, or RAG. This keeps the agent context-aware without needing to retrain the underlying model. Step 4 is actions and tools. Thinking is great, but an agent must interact with the world to be useful. Tools let the agent execute actions like searching the web, running computer code, or making API requests to external databases and software systems. Now, how do these four parts work together? Through a continuous process called the feedback loop, often using the react pattern: reason, act, observe, and adapt. The agent makes a decision, performs an action, looks at the result, and adjusts its next steps until the goal is finished. Let's see this in a real-world example. Imagine an e-commerce customer support agent handling a product return. First, perception reads the customer's email requesting a return. Next, the brain reasons through the task and checks memory for the company's return policy and order history. Then, the action component calls a payment API to issue a refund and uses an email tool to send a confirmation. Finally, the feedback loop confirms the email went through and marks the task as complete. To recap, basic AI agent architecture relies on four key parts: perception for gathering inputs, the brain for planning, memory for holding context, and actions for using tools. Combined with a continuous feedback loop, agents can solve complex tasks automatically. If you found this video helpful, give it a thumbs up and subscribe for more clear tech explanations. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Welcome. Today, we are talking about how AI agents work behind the scenes. Have you ever wondered what actually happens from the moment an AI agent turns on until it finishes its job? That process is called the agent lifecycle. Let's break it down in simple terms. An agent lifecycle is simply the sequence of stages an AI software agent goes through. It starts when the agent is created, guides how it does its work, manages when it waits for input, and safely shuts it down when the task is done. The first stage is initialization. Think of this as waking up the agent and giving it a job description. Here, the agent loads its system instructions, specific goals, available tools, and memory limits before starting any real work. Next comes active execution. This is where the agent actually does the work. It senses its environment, makes smart decisions using reasoning loops, and takes action like looking up data or using external software tools. Sometimes, the agent cannot finish right away. That brings us to pause and wait states. If the agent needs human approval or is waiting for external data, it pauses safely to save system resources and wait for a signal to continue. Let's look at a real-world example. Imagine an e-commerce refund agent. It initializes when a customer asks for a refund. It enters active execution to check purchase logs, then pauses to wait for the customer to upload a receipt. Once verified, it processes the refund and moves to the final stage. The last stage is termination and cleanup. Once the task is completed, failed, or timed out, the agent saves important progress, closes network connections, and releases memory. Proper state management keeps systems fast, safe, and predictable without wasting computer resources. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Have you ever wondered how modern AI systems don't just answer questions, but actually complete complex jobs for you? They use something called an agent execution loop. Put simply, an agent execution loop is a repeating cycle that an AI system uses to achieve a goal. Instead of giving a single quick answer, it constantly observes its environment, thinks about what to do next, and takes action until the job is done. At its core, this loop follows a simple continuous cycle often known in AI research as the REACT framework: reason, act, and observe. First, the AI observes the current situation. Second, it reasons about what step it should take next to reach its goal. Third, it executes that action using a tool, like searching a database or running code. Finally, it observes the result of that action. Then, the cycle repeats with the updated information. Let's look at a real-world example. Imagine an AI customer support agent handling a complex refund request. The bot starts by reading the user's message. Next, it reasons that it needs to check the order status, so it acts by querying the store database. Observing that the order qualifies for a refund, it then calls a payment gateway tool to process the money. Finally, it observes the success message and emails the customer a confirmation. Why is this execution loop so important? Older AI systems gave static, single-turn responses. If a task needed multiple steps or hit a roadblock, the old system failed. An agent execution loop gives AI autonomy. It breaks big goals into smaller steps, dynamically selects tools, and adapts based on immediate feedback rather than relying on one simple reply. System memory and state evaluation play a key role here. As the agent loops through steps, it keeps track of past actions and tool outputs in its memory. If a tool fails or returns an error, like a database timeout, the agent evaluates the issue, adjusts its strategy, and tries another solution to fix the mistake. However, we must ensure these AI loops stay safe and controlled. Without safety rules, an agent could run forever in an infinite loop or perform unwanted actions. Designers set clear guardrails, such as a maximum loop limit, explicit goal detection, and human approval for critical choices. To wrap up, the agent execution loop turns basic AI into powerful digital assistants that can solve multi-step problems on their own. By continuously reasoning, acting, and observing, AI agents can handle complex workflows reliably. Thanks for watching, and subscribe for more simple breakdowns of advanced technology. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Welcome back. Have you ever wondered why some AI tools just talk back to you, while others can do actual work on their own? Today, we are breaking down chat loops versus agent loops in simple terms. A chat loop is what most of us use daily with standard AI chatbots. You type a prompt, the AI reads it, gives an answer, and then completely stops. It sits idle, waiting for you to type the next message. It relies entirely on human interaction to move forward. An agent loop is totally different. Instead of stopping after one answer, the AI enters an automated cycle. It follows 4 continuous steps: analyze the situation, decide on an action, execute a tool, and observe the result. It repeats this cycle automatically until the job is complete. Let us look at a real-world coding example. Imagine a software engineer fixing a bug in a code repository. In a chat loop, the engineer must paste code snippets into the chat, ask for advice, copy the AI's response, edit the file, and run tests manually. In an agent loop, the AI autonomously opens the code files, runs terminal commands to test the code, edits the broken files, and verifies its own work until the bug is fixed. When should you use each? Chat loops are best for straightforward tasks like quick Q&A, writing emails, or summarizing text. Agent loops excel at complex, multi-step workflows like deep market research or automated software debugging. However, because agent loops act independently, they need strict safety controls. Developers set maximum step limits, restrict file permissions, and include human check-ins so the AI does not get stuck forever or make unauthorized changes. To wrap up, chat loops wait for your next prompt, while agent loops autonomously analyze, act, and learn until a goal is reached. Thanks for watching, and see you in the next breakdown. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Imagine asking an AI to plan a full 10-day trip to Tokyo, and instead of just giving you text, it actually finds your flights, picks the best hotels, and builds a customized itinerary. That is the power of advanced agent architecture. It is the design blueprint that transforms basic AI chatbots into smart digital assistants capable of thinking, planning, and using tools to complete big real-world tasks. Look at modern travel platforms like Expedia. They explore multi-agent systems where dedicated AI agents handle different jobs. One agent searches live flight data, another checks hotel room availability, and a main coordinator ties it all together. But here is an important safety detail: while the AI handles all the heavy searching and organizing, safety guardrails ensure you approve the final booking and payment yourself. How do agents solve complex goals? Through autonomous planning. Instead of guessing, agents use smart thinking frameworks like REACT, which stands for reasoning and acting. They break down a giant goal into smaller, logical subtasks step by step without needing a human to guide every single click. The second key pillar is tool usage, also called function calling. Basic AI models can only generate text, but smart agents can take action. They connect to external tools like web browsers, software APIs, and calculators to fetch real-time information and run tasks in outside systems. To stay smart, agents need memory systems. They split memory into 2 main types. Short-term memory keeps track of your current chat session inside the immediate context window. Long-term memory uses vector databases to remember your past preferences, facts, and learnings across long periods of time. For massive projects, one agent is not enough. That is where multi-agent collaboration comes in. Frameworks like AutoGen and Crew AI let multiple specialized agents work as a team. You might have a planner agent, a worker agent, and a critic agent who double-checks the work for mistakes. Finally, modern AI systems build in human-in-the-loop guardrails. This creates verification checkpoints for high-risk actions like spending money or sending emails, keeping AI helpful, accurate, and safe. Advanced agent architecture is turning simple text models into active problem solvers. Thanks for watching, and subscribe for more easy AI breakdowns. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Have you ever wondered why some AI chatbots can only answer simple questions, while others can handle complex jobs all by themselves? The secret lies in their architecture. Welcome back. Today, we are breaking down basic agent architecture versus advanced agent architecture in plain, simple English. Let's start with basic agent architecture. Think of a basic agent as a simple straight line. You give it an input, it processes the prompt, and it sends back an immediate output. It relies on direct instructions without remembering past chats or looking up live external tools. Because of this simple path, basic agents are super fast, cheap to run, and great for predictable, single-step tasks. For example, imagine a customer service chat box on a website. If a customer asks, "What are your business hours?" a basic agent simply reads the question and immediately replies, "We are open from 9 to 5. It does the job instantly without needing any complex deep thinking or outside tools. Now, let's step up to advanced agent architecture. Advanced agents do not just respond, they think, remember, and act. They connect short-term working memory with long-term databases to remember past conversations. Plus, they use reasoning frameworks like React or Plan and Solve to break big goals down into smaller subtasks. Let's look back at our customer service example. What if a customer asks for a complex refund? An advanced agent doesn't just give a canned answer. It looks up the customer's order history in a database, checks the return policy via an API, makes a decision, and automatically generates a shipping label for the return. It handles the entire process end-to-end. Advanced architectures often go even further by using multi-agent systems. Instead of just one AI doing all the work, multiple specialized agents collaborate like a team. For instance, one agent researches, another writes code, and a supervisor agent critiques and corrects the work to make sure everything is accurate. So, are advanced agents always better? Not necessarily. While advanced agents solve huge problems, they also cost more money in API tokens and take longer to respond. They can also make unpredictable mistakes. Basic agents, on the other hand, remain the best choice when you need quick, cheap, and reliable results. To wrap up, basic agents are like quick reflex tools for simple tasks, while advanced agents are like smart project managers built for complex, multi-step workflows. Pick the right architecture for your needs, and you'll build smarter AI applications. Don't forget to like and subscribe for more simple AI guides. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Imagine having a personal assistant who doesn't stare at you all day waiting for orders, but instead sits quietly until a specific signal happens, then jumps into action immediately. That's exactly what an event-driven agent is. They are smart software programs that stay on standby and automatically act whenever a specific trigger occurs. So, what is a trigger? A trigger, or an event, can be anything from receiving a new email, detecting a change in a database, or even a hardware sensor detecting movement. Instead of running code over and over to check if something happened, these agents wait for the event to be published. Let's look at a real-time example: smart home security. Imagine it's midnight. A motion sensor near your garage detects movement. That movement is the event. The event-driven agent instantly wakes up, turns on the outdoor lights, starts recording video, and sends an urgent notification to your smartphone, all in a fraction of a second. One huge benefit of event-driven agents is efficiency. Traditional programs often run constantly in the background, consuming electricity and computer power just checking, is there new data yet? Event-driven agents remain idle until needed. This conserves computing resources, lowers server costs, and saves energy. Another big advantage is speed. Because these agents react immediately to events, they provide ultra-fast, low-latency responses. This is critical for time-sensitive tasks like detecting credit card fraud the moment a suspicious purchase occurs, or sending instant customer support alerts. Finally, event-driven agents make software systems more flexible through loose coupling. This just means different software tools can talk to each other smoothly without being tightly glued together. If one tool breaks or updates, the rest of the system keeps working fine. To wrap up, event-driven agents save power by sleeping until triggered, respond in real time, and help systems work together seamlessly. Whether in smart homes, financial security, or cloud apps, they are changing how software gets things done automatically. Thanks for watching, and don't forget to like and subscribe. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Welcome. Have you ever wondered what happens when artificial intelligence can do tasks completely on its own? Today, we are exploring autonomous agents. Simply put, an autonomous agent is a smart software program or machine that makes decisions and completes tasks by itself to reach a specific goal, without needing constant step-by-step human control. So, how do these agents actually work? They operate using a continuous loop of 3 simple steps: sensing, thinking, and acting. First, the agent senses its environment through sensors or digital data. Next, it processes that information to decide what to do next. Finally, it takes action to move closer to its goal. A great real-world example of this is Waymo's self-driving cars. Inside a Waymo vehicle, an autonomous agent processes live data from cameras and sensors. It constantly decides when to steer, accelerate, or hit the brakes, navigating through traffic safely to take passengers to their destination without a human driver. What makes autonomous agents so useful is their ability to break big tasks down. Instead of waiting for a person to direct every move, an agent takes a large objective, like planning a trip or delivering a package, and automatically breaks it into smaller, logical action steps. Autonomous agents exist in 2 main forms: digital and physical. Digital agents live inside computers, like AI coding assistants or customer support software. Physical agents have real bodies, like delivery drones, warehouse robots, and autonomous vehicles. Even though these agents can work on their own, human oversight is still extremely important. Having a human in the loop helps set boundaries, review outcomes, and create strict safety guardrails so these systems remain helpful and safe. In summary, autonomous agents perceive their world, reason through complex goals, and take independent action to complete tasks. As AI continues to grow, these intelligent agents are reshaping both our digital and physical worlds. Thanks for watching, and stay curious. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Imagine you hire a super-fast assistant who works 24/7. But sometimes, they misinterpret an email and almost hit send on a huge mistake. That is the big challenge with full AI automation today. While AI is fast, it lacks human common sense. That's where human-in-the-loop agents come in. So, what is a human-in-the-loop agent? Simply put, it is an artificial intelligence system that performs tasks automatically, but relies on a human to approve decisions, fix errors, or step in during confusing situations. Instead of giving 100% control to the machine, the human stays in the loop as a safety net. Let's look at a real example: customer support. When you message a company, an AI agent can instantly read your ticket and draft an answer. But before that message reaches you, a human support worker reviews it, makes small tweaks, and sends it. You get a fast answer, and the company makes sure the answer is accurate and warm. Why is this combination so powerful? Because it gives us the best of both worlds. AI brings incredible speed and scale, handling thousands of tasks at once. Humans bring context, ethics, and emotional empathy. Together, they create a balanced workflow. This setup acts as a critical safety barrier in high-stakes fields. Think about healthcare, finance, or self-driving cars. In medicine, an AI might scan an X-ray to spot potential problems, but a real doctor makes the final diagnosis. Humans keep control where mistakes could cost lives or money. Here is another great benefit: continuous learning. Every time a human corrects an AI agent, that edit acts as feedback. Over time, the AI learns from human choices and becomes much smarter and more accurate. Finally, keeping humans in the loop maintains accountability. A computer cannot take moral or legal responsibility for a major decision. Humans must remain the ultimate decision makers for critical choices. In conclusion, human-in-the-loop agents are not about replacing people. They are about combining machine speed with human wisdom to make AI safe, effective, and reliable. What do you think about working with AI agents? Leave a comment below, and don't forget to like and subscribe. Please subscribe, like, and share. Thank you. Welcome to KKPBT Online Training by Vicky. Have you ever wondered how AI is changing from a simple chatbot that just talks to an active assistant that actually gets things done? Welcome back. Today, we are exploring basic agent flow. A basic agent flow is the step-by-step process an AI follows to receive your request, plan its actions, use external tools, and check its own work. Instead of just giving you an answer, it solves multi-step problems all on its own. At the heart of every agent flow is a continuous loop. It doesn't just guess what to say next. First, the AI reads your request to understand the goal. Second, it creates a plan. Third, it executes an action. And fourth, it looks at the result to see if the job is finished. This cycle of reasoning and acting is often built using an architecture called REACT, short for Reason and Act. Let's look at a real-time example. Imagine an e-commerce store handling customer returns. When a customer asks for a refund, a basic agent flow kicks in. The AI reads the email, checks the customer's order in the database, reviews the return policy, and if everything matches, automatically emails a return shipping label right back to the customer. It handles the entire task from start to finish without needing a human to click a button. Standard large language models are great at writing text, but they are limited to what they already know. Agent flows supercharge these models by giving them access to external tools. An agent can search the web, run calculations, query a database, or connect to external APIs. This allows the AI to gather live information and perform real actions beyond simple text generation. Another core feature of a basic agent flow is task decomposition. If you ask an agent to perform a huge, complicated job, it doesn't get overwhelmed. It breaks the big task down into smaller, manageable subgoals. By solving these small steps one after another, the agent stays on track and completes complex projects far more reliably. What happens if a tool fails or an API goes down? A standard program might just crash, but an agent flow includes error handling and reflection. If an action fails, the agent stops, evaluates what went wrong, and tries a different approach. This ability to replan makes AI agents incredibly resilient when facing unexpected real-world problems. To wrap it up, a basic agent flow turns static AI into a dynamic assistant. By combining continuous reasoning, tool usage, task breakdown, and self-reflection, agent flows power the next generation of smart automation. If you enjoyed this quick guide, make sure to like and subscribe for more simple AI explanations. See you next time. Please subscribe, like, and share. Thank you.